Okay, hello guys, welcome to Master the Code, and today we are going to talk about the last question of Codeforces round 957 division 3, that is ultra meow. Okay, so the person K10ON gave you an array of length n consisting of numbers between 1 to n, and we need to calculate the meow of the array A. Okay, so let mex of s comma k be the kth positive integer in ascending order that is not present in the set S. Then we denote meow of A as the sum of mex of B given the size of B plus 1 over all distinct subsets of B of array A. Okay. Now examples of mex of s comma k values for set are given as follows, and the test cases are 10 to the power 4 and the value is within 5000, and it's guaranteed that the sum of n square over all test cases does not exceed 25 into 10 to the power 6. That means we can run two for loops over the entire n once. And for the test case, output a single number. Since it may be very large, output it with a power of 10 to the power 9 plus 7 to the mod. Okay, so let's understand the question first, what the question means. Suppose we have an array from 1 to n. It contains numbers, let's say 1, 2 and 3. First we need to evaluate the mex of all subsets. First we need to evaluate subsets. So one should know what are subsets actually. Now first we need to define the subsets. The first subset is the empty, then we have 1, then we have 2, then we have 3, 1 comma 2, 1 comma 3, 2 comma 3, and finally the entire array. So this will be the subset. The number of subsets are again 2 power 3, that is, you can say 2 power n, the number of elements. Now we need to reduce this time complexity of 2 power n to order of n square. So these are subsets. Now what is mex? Mex of will contain two values. First a set and then a number k. Suppose a set is 1, 2 and 3 and k is given number 1. Now what mex says is, if you are given a set of 1, 2, 3, then you need to find the next kth positive number which is not present in the given set. Since the value of k is 1, the next positive number which is not present in the set, that is 4. Another example, if we have 1, 2 and 5 and k equals to 2, the values which are not present in the set are 3 and 4, and the second value is 4, so we will return 4. Now in the question there is a little bit of change such that mex of a given set B and the value of k is given the size of the set plus 1, such that if the set is empty, the value of k will be 1 and the output will be 1. If the set contains 1 and 2, we need to keep the size as 2 plus 1, that is 3, and the output will be the third element which is not present in the set in ascending order, that would be 5, since 3, 4 and 5 are not present and 5th is the third element. And then we need to evaluate the sum of all these values. So I hope the question makes sense. Now we need to solve this question. This question is a problem of combinatrix. And we need to evaluate all the possible cases. So for I equals to 1 to n, the mex of a maximum number of any number k will range from k plus 1 or not even k plus 1 to k itself and 2 into k plus 1. Why? It is because of this given constraint. Like you can see, if a set is given of size 2, the maximum value which the set can ever attain is size of the set plus 1. So if it contains two numbers, that is 1 and 2, the next three numbers will encount the value of MEX. So 2 plus 2 plus 1, that is within, before 5 or by the end of the reaching 5, we will get our MEX. So that is the bound for k which we needed to evaluate first. That is our first hint. And for this, for each value that can be an MEX, we will find out the combinatrix or the sum of the entire array. For that, we can do the total and keep it k. The MEX can occur more than once as well, because suppose if you have a set of 1 comma 4 and 1 comma 5, the values are 3, right? Or let's keep it a bit more simple. If we have one set that is 4 and another set that is 5, the value of k is 2, and in each the output will come 2, because 2 is the second element which is not present in the set. So MEX can occur more than once, so we are multiplying it k times, and we will find the combinatrix, that is combination of C given j plus 1 and j minus I plus 1, which will again be multiplied by n minus j and I minus j minus I plus 1. This is the mathematical thing which you need to keep in mind while solving this problem, because we are evaluating all the possible cases before and after that particular index. So using this particular formula, you can very easily find out the exact number, and in the end you would need to do the percentage mod with 10 to the power 9 plus 7 as per the given question. So if you, now we will jump into the code and see how this entire procedure is carried out, and for that please like, share and subscribe to the channel and hit the bell icon for more notifications. Okay, so in this particular question, what I did, I took the values, required values, created the factorial inverse arrays, inverse vectors, updated them using the, since we need to evaluate the NCR, these two functions I used to evaluate the combination values for the given values of n and r, and for that I did the inverse array for storing the denominator and factorial for storing the numerator, and then did the mod with them as per the question required in the question. Then this was the function which was run for the t-test cases. And then in the simply, I use the two loops, one within range 1 to n plus 1 and another within range from I plus 1 to 2 into I plus 2. Like since it will be running to till 2 into I plus 1, so I ran it to till 2 into I plus 2. Use the combination technique to evaluate the combination required, since the function was we discussed and was explained in the theoretically. We implemented it in code, and this is how it looks like. Taking the minimum of n, either n or j minus 1, and updating it, or rather evaluate, this is the n value for the combination function, and this is the r value. Then I did n minus j for similarly for the n value, and I minus j minus I plus 1 for the r value. and and then this entire thing is done with the percentage mod to keep it within the value of 10 power 9 plus 7, and then again multiplied by g, and then again, in case if the value exceeds more than the maximum prime number that can be stored in an integer, it is again done with the same mod value, and then it is printed and we get the results which are passing all the required test cases. So I'll be sharing the code in the description down below as well. Please feel free to like, share, and subscribe to the channel and hit the bell icon for more notifications. I'll be sharing more codes and solving more questions as well. Also, within the next week, I will be sharing some important questions related to Microsoft and Google as well, which are asked in the STP internships and for the newcomers, for the freshers. So please stay in touch, and I will be posting much more interesting and intuitive videos with various ways of solving questions as well. So pretty soon. Until then, have a nice day and bye bye.